All right, this video is to show you how to convert a screen slope, that is a screen velocity, into a real velocity. And I've already calculated using my Google Graph a screen velocity of 7.5 centimeters per second. If I was doing this by hand, I'd need to show my work here, but I use the computer, so I'm not going to do that. What I now need to do is to get this in actual real meters per second. I know this is how fast it was moving across the screen, but that doesn't actually tell me how fast this thing is moving in real life. So what I need to do is come up with a conversion from the actual video of basically like how much a screen centimeter, how much distance a screen centimeter is equal to in real life. So for example, I know that this is 2 meters tall, and I can see the top of it and the bottom of it. I can put my ruler against this and see that this is 2.5 centimeters, and that's equal to 2 real meters. So I'm going to use that as my conversion factor. I'm going to say 2.5 centimeters on the screen equals 2 meters in real life. It's important to recognize we're not saying that 2.5 centimeters is actually equal to 2 real meters. We're saying that on the screen 2.5 centimeters is the same as 2 meters in real life. So I can then use this as a way to convert from screen centimeters to real meters in real life. And here's how I do that. I'm going to write my screen velocity, 7.5 centimeters per second, and then I'm going to multiply it by a number that's basically, it's going to be equal to 1. If we think of dividing both of these sides by 2.5 centimeters, 2.5 centimeters on both sides, this is going to cross out and equal to 1, but this is going to be a useful way to convert from this number to real meters. So I'm going to multiply by 2 meters divided by 2.5 centimeters, and when I do this multiplication, the centimeters are going to cancel out, and I'm going to be left with real meters per second. So check this out. I'm going to take the number 7.5. I'm going to multiply it by 2 on the top of the fraction, and then I'm going to divide it by 2.5 on the bottom of the fraction, and it looks like I get the number 6. So this is going to be equal to 6 meters per second in real life. I'm saying that my actual velocity, the thing I dropped off that roof, is moving at 6 meters per second when it hit the ground, based on the screen calculation that I did here. Based on that constant velocity section that I fit to, I know that in real life this thing hit the ground moving at 6 meters per second. Now I'd still want to justify how this works. I would want to explain how I measured numbers on the screen, and I need to convert them to real numbers. And again, the whole idea of this, the reason why this works, is we're saying that for every whatever this is on the screen, like 2.5 meters, that corresponds to a real life distance of 2 meters. So if I know that the thing is moving across the screen at 7.5 centimeters per second, I know it's moving in real life at 6 meters per second. Your number for this is going to be different than mine. You're going to need to make that measurement yourself to get a different number here, but this process will be the same for you as it was for me, just with a different number here.